All right, I'd like to talk about power for this one, you guys. But to talk about power, I have to back up just a couple slides. We already talked about work, and work is simply defined as a force over some unit of distance, kind of transferring some energy. And so we've got that definition, some force used to move an object. And so, in order to work, we talked about some different definitions, things of that nature. And when we look at this equation, if I look right here, this distance piece, if distance equals 0, well, any number, any force times 0 would be 0. So, kind of like momentum, work requires motion. If you don't move, then you don't work. And so that distance is an important piece. And so, we gave that example. If you're pushing, your car is stalled and you got to push it into the garage so it can get work done, and you push and push and push and push, and the car just doesn't move, yeah, you might be tired. You were using energy, but according to the definition, since the car didn't move, you didn't do any work. And then we look at the label, the label for work. Remember, force is measured in a Newton. Force is measured in a Newton. Distance is measured in a meter. So our label is a Newton meter. Sometimes written like this, Newton meter. And then down here, 1 joule equals 1 Newton meter. And so that's what we talked about with work, and we're going to need a little bit of that as we move forward with power. And so that's what I want to be the main focus of this one. So talked there already, mentioned a few things there, should have filled those in, just some different things. But here we go with power. And so we have this idea that work is force times distance. It's basically a transfer of energy. You're transferring your energy to something. And so then we look at power. Power is very similar, and we just bring in a time increment, the rate. And so we do work, and so we take force times distance. And then the rate we do that, what we're going to end up doing is dividing by time. And so we're going to see force times distance divided by time. And so I look at this equation right here. I have work divided by time, which looks like that. But then what we can also do, since work equals force times distance, we can take the same equation and write it like this. P equals F times D divided by T. And so we end up with two different equations for power. We can take work divided by time, or we can take force times distance and divide it by time. And then the unit for power, this was studied by a gentleman by the name of James Watt. And so we see his name right here, his last name, James Watt, just like James Joule for work. James Joule did a lot of studying there, and so we use joules for work. James Watt did a lot of studying here, and so we use watts for power. And so 1 watt equals 1 joule per second. And remember, we saw this already, 1 joule equals 1 Newton times a meter. So this also equals 1 Newton meter per second. So again, I've already mentioned this, you guys. Labeling is where we start to get some issues, and we're seeing that now. The math, we've seen equations with division, we've seen equations with multiplication. You guys are doing well with that, and I'm glad for that. In the physics realm, we just have to get used to labels. And so there we are with power. Power is just bringing in the time. If you're getting the work done faster, you have more power. If your friend is getting the work done slower, they just have less power. This term is starting to work its way out. We're not seeing it as often. There we go. This was some of James Watt's original studies. He improved the steam engine. He didn't create the steam engine. He just improved it, and he wanted to make it marketable so he could sell it to farmers and make money. And so it was hard for him just to go to a farm and say, "Hey, please buy my steam engine." And the farmers would be like, I have no clue what that thing is. I've never seen it before. Why would I buy that thing? And so James Watt studied horses, tried to figure out the power that they had, and he came up with a relationship. And he said, my steam engine has 2 horsepower. and which would mean it has the power of 2 horses. And to a farmer, that would make sense because horses did a lot of the work on farms. And so if he's explaining to a farmer, if you buy this big metal contraption that I call a steam engine, you can replace 2 of your horses and it will do the same amount of work, and it doesn't need to take a break, and you don't have to feed it in the wintertime. And so this idea of horsepower came to be. We use this conversion right here, and again, it's starting to phase out. We don't use horses much anymore, but 1 horsepower is about 750 watts. If you go to a standard light bulb, 1 horse could power about 12 or 13 light bulbs for the course of a day. And so like now some of these car engines right here, I don't know what horsepower that engine is, but maybe it's a 150. I'll do HP for horsepower. That's how we would use that. And so we would rate that engine in relation to a horse, and that's where that term horsepower came from. And so that was in use for about 300 years. We don't use horses much anymore for labor, and so now we're kind of going away from that. And some of you that are into engines, cars, and things like that, you might see this, CCs, and that stands for cubic centimeters. And so now engines more so are rated by cubic centimeters. So it's just where the term originally came from, and with changing times things have varied a little bit. And that brings us to our last topic, energy. It's an ability to do work. So work, we could define work this way. Work could be defined as a transfer of energy. This guy here, he's lifting those weights up. Let me see if I can get a different color so you guys can see that better. He's lifting these up, so he's lifting those up. And so what he's doing is he's transferring some of his energy to those weights. He's doing some work. Force times distance. We could get his power. We could ask, time him, see how long he's doing that. And so now energy is this ability to do work. And so he's transferring energy to these dumbbells. Well, this ability to do work as he's transferring energy, if he keeps that up, any of you that have been in a weight room before, you keep doing repetitions, well, your muscles get tired. Well, your muscles only have so much energy. And eventually you're going to use up all your energy and you just can't lift the dumbbells up anymore. And so energy is an ability to do work, and so oftentimes you have an ability to do work. For example, if I said go clean your room, you have the ability to go clean your room, you have the energy. That doesn't mean you're going to do it though. So energy is simply stating it's an ability to do work. Doesn't mean you're actually going to do it. When mom and dad say, empty the dishwasher or go mow the grass, you all have the ability to do that, which is to go do the work. You just may choose not to. And so energy is that ability to do that work, which is that force times distance.